Welcome to Google Cloud's digital conference, Let's Talk AI. I'm Lak, a tech lead for data and machine learning at Google Cloud, and with me is Gaurav Tandon, Director of Data Science and Machine Learning at Zulily. Welcome, Gaurav.
Thank you, Lak.
Today we're going to be talking about preparing your data for machine learning. We have Googlers on standby to answer your questions live, so please click on the icon to your left and ask away. When we talk about machine learning, we're talking about data that we need to prepare. Why do we need data to prepare for machine learning? Can't we just use the raw data? Well, it turns out that machine learning, what you're doing is that you're teaching a computer by showing it lots of examples. The traditional way that you teach a computer, of course, is by programming the logic, by writing a bunch of rules. But in ML, you change that around. Instead, you show it a bunch of examples that all have labels. So for example, if you want to teach a computer to identify what's in an image, you give it a bunch of images, and corresponding to each of those images, you say what the true answer is, the label. So in our case, in this example, we might say that the first image has a cat and the second image has a dog, and then we feed it into a standard algorithm called a machine learning model that is then trained, or whose weights are changed in such a way that the output of the model corresponds to the label that we said was a correct answer. So when we talk about machine learning, we're talking about a huge amount of collaboration because of this data pipeline. So machine learning involves collaboration between data analysts, data engineers, and data scientists. So we often think of the data scientists as creating the model and training the model. But before they can train the model, they have to have the data. And domain experts and data engineers typically identify and gather the appropriate data with some input from the data scientists. But this is something that everyone, all the business people at the company do. And then data scientists join the appropriate data, engineer features, create and train models. But that model by itself has to be used in production, and that then falls on the data engineers, who need to maintain the training and prediction infrastructure. And then, of course, once you have a trained, deployed model, everyone needs to monitor different aspects of model performance. So throughout this talk, Gaurav and I will show you how many of these requirements play into the kinds of things that you need to do on your data pipeline to make your machine learning predictions actionable. So one of the key differences between traditional statistics and machine learning is how you deal with outliers. When I first started working with prediction problems, I was using statistical techniques. And what do you do with a statistical technique when you find an outlier? You throw it away, right? But you can't do that with machine learning. The whole idea behind machine learning is, of course, that you're training it on large amounts of data where the outliers will happen at production time, and you need to have a prediction for those outliers as well. Now, if you have a customer who spends $1 million a month, you want to actually have recommendations for that customer. You don't want to say that customer is an outlier, and so we're not going to do predictions for them, right?
Absolutely.
That's absolutely right, right? So the idea is that we want to understand the reason that outliers occur and collect enough examples. So to talk about how Zulily applies this technique, Gaurav.
All right, thanks, Lak. First, a quick introduction around Zulily and what we do. So Zulily is an online retailer that introduces a third way to shop. Unlike brick and mortar retailers and traditional online retailers, which are focused on intent-driven directed search. So you need cat food, you go search for cat food in the bar, find the relevant results, pick the one that's most relevant to you, and go from there. Zulily presents a browse and discover based experience.
So for people who may not quite yet know what they need.
Yes. And the goal is to make it an engaging experience for people to come back and make it fun and entertaining. And how do we do that? We launched 9,000 to 12,000 styles every single day through collection of over 100 events. We're working with over 15,000 brands. Some of them are large, well-known brands, and some of them are small boutique brands that not everyone has heard of. So where are we today? We have a great traction on mobile platform. In fact, 71% of our orders are coming on mobile devices.
As people are out and about.
Yes, absolutely. So we are where our customers are. And our business model is interesting. I mentioned we are launching 9 to 12,000 styles every single day. So it poses interesting problems that we're aspiring to solve with machine learning.
And even when someone is discovering, you need to know which event you need to basically position at a particular customer.
Absolutely. So at Zulily, I'm working with multiple teams of data scientists, data and ML engineers to solve a bunch of problems. One of them is driving customer engagement. Right? We want to enable discovery, so we present a one-to-one custom-tailored experience to all of our customers. And as a result, 91% of our orders today are actually coming through repeat customers. There are other problems that we are trying to solve. What channel to reach a customer on, what time, and what should the content of the message be? And we've actually achieved a lot of success doing that. As a matter of fact, we had 49% increase in demand year over year just through mobile push notifications, which were personalized and catered to that specific
customer.
Who
wouldn't love a 49% increase?
Absolutely. And one of the other challenges is around the dynamic nature of our catalog, because our products are changing, events are changing every day. So it's a hard problem to figure out, what kind of merchandise should we launch tomorrow, or what should that assortment look like.
And in fact, what you sell tomorrow has not been part of any event previously.
Absolutely. So novel data is
novel data. That's a very interesting problem.
That is, yes. We're also working in the acquisition marketing space, trying to make recommendations on what kind of ads to launch, bid optimization. We also have 3 fulfillment centers here in the US. So we're using machine learning to bring in efficiencies there so we can actually
logistics
improve the overall customer experience. So all of that together is driving engagement for our customers. So I think before we get into the outliers and how we deal with outliers, I want to emphasize on the importance of data. Without data, there is no machine learning. And so getting the data right is critical. It is the strong foundation that you can build ML on top of and reap all of the benefits. So for Zulily, we work with different kinds of data. Some data we are trying to ingest in near real time. This is around what our customers doing. So we want to listen to our customers and make changes accordingly. So it has to be near real time. But there are other data sets which we are ingesting at varied cadence. So these are running as batch jobs, which we are running every so often, and aggregating the data sets. So 4 years ago, Zulily made the transformation into the cloud. When we came on board the Google Cloud Platform, we are using Google Cloud Storage as our data lake, and we chose BigQuery as our data warehouse. This was more around the democratization of data, making the data available to everyone so they could make data-driven decisions for their day-to-day as well.
And this is an important point. You're making it available to everyone within your company. You're democratizing the data to all of the folks making business decisions.
Absolutely. So here we have analysts who can derive insights from the data. We have data scientists who can run their exploratory data analysis on that data, which drives into all of the model building for machine learning.
This is one of the huge benefits of having it on something like BigQuery or something on cloud storage is this broader access. It's
Absolutely.
not sitting on a cluster somewhere.
Yes, and it makes sharing the data sets and the metrics really easy as well across the business, brings in standardization, so everyone is speaking the same language. And these are also the data sets that we are actually using in production for our machine learning data pipelines as well. So coming back to the outliers. So machine learning algorithms are very sensitive. Well, it depends on the algorithm itself, but they're kind of sensitive to the range and the distribution of the feature values themselves. Data outliers can actually spoil and mislead the training process in some cases, resulting in longer training times and sometimes less accurate model where you will then invalidate the results.
Right, where the model is being drifted because of the presence of those outliers.
Absolutely. So it is imperative to detect outliers in the first place. So at Zulily, we've built a platform that can monitor the data and then detect if something has deviated significantly from the norm, and then flag it. But detection of outliers is just one aspect of the problem. I think the other is understanding what those outliers actually mean, because there's a lot of things around, oh, is this just corrupted data which was introduced by a new bug in the code push that just happened?
Or is it a new event?
Or is
a new
it
product?
Absolutely. Or is the underlying distribution of the data changing? And the latter is what we are really interested in, because we want to be able to learn that, incorporate those data points, those examples, to retrain our models so we are able to make the paradigm shift and have our models accommodate all of the novelty that's coming into our data.
And the other question that often comes up is, so you have data that you're collecting. Why do you need to extract it, transform it, load it? Why do you need to modify this data that you're collecting? Why not use the data as is?
So that's a great question, and PCA is principal component analysis is a technique that has been used to create word embeddings. Given a set of instances like bag of word vectors, PCA can find highly correlated dimensions that can be collapsed into a reduced set of dimensions or a single
instead of
dimensions.
training on the raw data, which might lead to really hard problems because there are so many of words, you're essentially taking similar words and grouping them together and being able to train on clusters of customers, clusters of products, clusters of things.
Absolutely. Word2Vec is another popular algorithm of choice. And one of the interesting things is once you're able to do that, you can reuse these embeddings as features into the machine learning models as well. And that's really interesting. So at Zulily, we are continuously listening to our customers so we can give them what they want and improve their customer experience further. And so one of the things that we did was we applied PCA at the product level based on a lot of customer feedback that we were getting. And a surprising product quality distribution appeared from that. And this embedding is actually directionally appropriate across the embedded features themselves. And it gives us a simple, scalable measure for the quality itself. And this is something which we have been able to reuse in different scenarios and also build these as features into.
And this is amazing because you sell so many different types of products and you're able to take the metadata about all of these products and are able to assign a single scalar quality metric to it. And then you're able to say that some customers go on different parts of this quality spectrum.
Right, and if there are, we absolutely want to sell the best products to our customers. So, there's something that's actionable for us as well, where we only want the best quality products to be sold to our customers. So I think, and from that perspective, just being able to reuse this, not just by itself, but also as a feature that goes into other machine learning models has been immensely helpful. Feature engineering is where the most gains can be made in modeling. You have your algorithms, but it is the features that are derived from human insight that make all the difference.
Yeah, because the algorithms are actually standard.
They're standard.
Right.
Yes, absolutely. And so from our understanding of the data itself and working with domain experts, we determine what are new features we can incorporate in the models and also which ones should we actually keep in our existing model. So we are not only relying on our domain experts for that, but we're also querying the data that we are gathering from the customers themselves. So an example is we maintain a distribution for each customer's product preferences based on Bayesian updates. And we can actually look at
two groups of customers.
There are one which are likely to buy something compared to the others. And so here we can actually drill down and see how our customers are behaving
Their
and
propensity to buy.
their propensity to buy, what do they need, and how we can actually help them get what they want to get. And one of the other things I want to just call out is we need to ensure that bias doesn't creep in. So it is
Fairness is a very important thing, and it's driven a lot by the data that you train your model with.
absolutely. So we need to ensure that we gather lots of it. So next, I want to go over Zulili's approach to machine learning. So again, around 4 years ago, we wanted to use machine learning to solve a wide variety of problems so we can actually give our customers the best experience possible. And so early on, we invested in workflow automation for machine learning. So we wanted to build a platform that enables reuse. That's reuse of features, reusing the algorithms themselves, but also be able to distribute the workload to handle the vast amounts of data, whether it's around feature generation, using joins or transformations, normalizations over raw data, or model training itself. And then we wanted to present the inference as a microservice, deployed as the container in the cloud. And so there were a lot of choices that we made with all of those things in mind. So we built a feature generation framework using Spark. So we were able to look at all of the different data sets, the raw data sets, do the aggregations, transformations, normalizations at scale, build all of the features that can go into the model, and then do the model training in a distributed fashion on the cloud itself. So like I mentioned, the raw data sets sit in BigQuery and Google Cloud Storage. The model training is actually happening on Dataproc clusters. And then the inference is really a service that we deploy on the cloud
Kubernetes.
engines. Yes, and using Kubernetes. So that was the other thing where we wanted to build this framework in a sort of cloud agnostic fashion. Mm-hmm. And so that's why Kubernetes and Spark are key.
Or open source frameworks that you can run on Google Cloud, but you can also run somewhere else.
Right. So, so that has been a model, an approach that we have successfully used for the past 4 years.
Great, great. So as Gaurav pointed out, right? So there's a architecture. You saw a whole bunch of hexagons. So let's kind of fill out the architecture some more. The key idea is that you store your data on a data lake, Google Cloud Storage, or in a data warehouse in BigQuery, or possibly if you have real-time Internet of Things data, storing it in something like Cloud Bigtable. The idea is that the storage and the processing are separate. So you choose your storage mechanism depending on the type of data, and then when you're ready to process it, you can process it using Apache Beam on Cloud Dataflow, on Apache Spark on Cloud Dataproc, or writing BigQuery, writing SQL statements. So different ways of doing the processing, and the idea is that all of these are ephemeral jobs that come up, they do the processing, and they go away. And you have different types of software for different types of data sets. Dataflow being an extremely good thing for unstructured data, and BigQuery being an extremely good approach for structured data sets. And Cloud Dataproc, if, as Gaurav said, you want to basically retain this ability to do things on the cloud, on our cloud, on other clouds. Okay. Similarly, for machine learning on GCP, again, the architecture is that you have data. Let's look at the bottom line. You have archived data, let's say, stored in cloud storage, and you can process it with Cloud Dataflow or Cloud Dataproc, and then save it into BigQuery and use that to train your machine learning models. And the idea is that, as Gaurav said, you basically want to end up with a microservice. And one way that you could do that is you could get real-time data as it streams in into PubSub. And using Dataflow, you can use the exact same code that you did on your historical data. The same code works on the real-time data. And therefore, the same pre-processing is being done. And the model that has been trained is then invoked to basically serve out your predictions. So you have the reference architectures for ML on GCP and data processing on GCP, and every customer that we talk to uses an adaptation of this, and Zulily is no different. Okay. But once you have a machine learning pipeline, once you have your data processing pipeline, we need to monitor this pipeline for data changes. Okay. And why do we need to do that? It's because while you're training the model, you're essentially always focusing on, you have your input data, you're pre-processing it, you're creating features, you're tuning your model, and you've deployed your model. At that point in time, all of your processing is in terms of running experiments. You're basically trying to figure out what parameters to use for your machine learning models. Do I do this type of feature processing or some other type of feature processing? And the way you decide that is through model accuracy. But then you turn around and you've deployed your model. The model accuracy is no longer the big thing. Now you need your service to be up. You need things to be reliable, and you need the model to be accurate. So for the service reliability, you monitor certain things. And for the model accuracy, you monitor the inputs to your machine learning model to make sure that the assumptions by which you trained the model, those haven't changed. Okay? And to think of what would happen if those changed, you've got to remember that when you train a machine learning model, you train it on a bunch of inputs. So let's say we've trained a model to train on whether you need to carry an umbrella or not. And you may have a variety of different inputs, and one of them might be a weather model. And then you turn around, you've created your model, and then you go ahead and put it into prediction. And at that time, the person who gives you the weather forecast, they change their model. And so now, rainy days are slightly more frequent than they were before. The underlying climate hasn't changed, but the model has changed. And that essentially means that your output probability is going to be completely out of whack. And so that's a very, very, very important thing to realize, and one of the things that you monitor for.
Yes. So not only we experiment with our machine learning platform, we are running experiments on every customer-facing aspect of our business. Machine learning strategy is more around iterate and test. It is about continuous experimentation. You start with a hypothesis, you then train a model, put it in production to validate that hypothesis, and then you incorporate your learnings into the subsequent iteration of the model itself. So at Zulily, we have our own statistical analysis tool where all of our results from the ongoing experiments make their way into BigQuery, and then we do the aggregations and then run statistical tests of significance, bring in the confidence intervals on the different metrics that we care about for that specific experiment, and use that to make a more educated decision on how to take that experiment. So this is an ongoing and a continuous experimentation process we use at Zulily. One of the other things, like you mentioned, was the data distribution changing.
The world changes behind you.
Absolutely, and as these assumptions change, you need to ensure that you are getting all of the new data in, keeping it up to date, and training on that data to be able to make sure you're keeping up to date.
And looking at that graph, I see the lift going down, and that's got to be very concerning.
Yes, absolutely. I mean, these are two examples where we can see, what happens if you don't change the model itself, or if you were to change the cadence of when you actually train the model. So in the plot above, the different plots are actually different training intervals. So in one case, the model is trained every day. In another case, it's every week, and so forth. So you're looking at the absolute mean residual plots, and you see actually the errors are much higher if you were not retraining.
And so the orange is the best.
The orange is the best.
And you're training more frequently.
More frequently for that
staying
specific.
Up to date.
Yes.
Right.
And so this is something you can do in an offline setting without really launching your code to production. But that is, again, telling you and giving you insights on when you actually should retrain the model for that given problem. The one on the bottom is another one that if you were not to train the model or change the model, how does that impact business metrics? Mm-hmm. And the plot there can demonstrate that it actually degrades over time, and you can see that it's gradually declining. Mm-hmm. And so this is a great example where you need to understand what the implications are and then being able to adapt to the underlying distribution changes over time and retrain and push new models into production.
And that's absolutely correct. So, and this is something that people who've been doing ML for a long time immediately realize is that, yes, you cannot just train a machine learning model and then go home. It is a continuous process. As new data come in, as the world changes, you continuously have to retrain. And I love these graphs because they show both from the top, theoretically, yes, if you train more often, you will get better results. But the bottom saying that, yes, it actually affects business metrics. It affects our dollar revenue.
Absolutely,
makes
yeah.
a
So
huge difference.
monitoring for these models is key. Monitoring for all the data inputs and how they're changing over time.
Right. So to summarize then, right, if you're going to be preparing your data for machine learning, it involves, number one, making sure that your data is accessible to everyone within the organization so that they can give you ideas on what features that you can be creating and they can look at the dashboards, et cetera. Secondly, to constantly look for outliers, things that violate the assumptions of your machine learning model. Thirdly, then, monitoring the produced model on the other end, creating and running a whole bunch of experiments, and then making sure that as the data distribution changes, you go back and you retrain your models.
Yes, absolutely. Those are all critical.
Okay. So thank you for joining us today. Please stay tuned for the next session. We hope you enjoy the conference.